In the third part of Precalculus Lesson 17, we will use the properties of logarithms in solving equations. This is section 4.2 in the College Algebra textbook. Let's get started by solving the equation 3 raised to the power of 2x equals 5. I start by taking the natural log of each side of this equation. So I have the natural log of 3 raised to the 2x equals the natural log of 5. And then using the exponent property, I can pull the 2x out in front of natural log of 3. And once I've done that, I can see that on the left-hand side here, I have x times 2 natural log 3. On the right side, I have natural log of 5. So if I simply divide both sides by 2 times the natural log of 3, I end up with x equals the natural log of 5 over 2 times the natural log of 3. And we have a solution. We want an exact solution here. We do not want a calculator solution. So make sure you solve this particular type of problem exactly like this. Now, using logarithms to solve the exponential equation, 7 raised to the power of 3 plus 7x equals 3 raised to the power of 4 minus 2x. This solution looks a bit messy, but this is the way to do it. So we start by taking the natural log of each side of the equation. The natural log of 7 raised to the 3 plus 7x equals the natural log of 3 raised to the power of 4 minus 2x. Now I can pull 3 plus 7x in parentheses out in front of the natural log of 7. And then on the right side of the equation, I will pull 4 minus 2x out in front of natural log of 3, making sure I put parentheses around 4 minus 2x. On the left side, we'll distribute through the natural log of 7 to give us 3 times the natural log of 7 plus 7x times the natural log of 7. On the right side, distributing through natural log of 3, we have 4 natural log of 3 minus 2x natural log of 3. Now, as we've done in other problems in the past, we want to get all terms with x on one side, everything else on the other side. So let's use the left side for x terms. I have 7x natural log of 7, and then I'll add 2x natural log of 3 to both sides. On the right side then, we have 4 natural log of 3, and after subtracting 3 natural log of 7 from both sides, the right side is 4 natural log of 3 minus 3 natural log of 7. We're almost done. So what I want to do on the left side is factor out the x. I have x times 7 times the natural log of 7 plus 2 times the natural log of 3. The right side doesn't change yet, but it will shortly. And then I'm going to divide through by 7 natural log 7 plus 2 natural log 3. So our final answer is x equals 4 natural log of 3 minus 3 natural log of 7 over 7 natural log of 7 plus 2 natural log of 3. Okay, and we want the exact answer here. We do not want a calculator approximation. Now, to solve the logarithmic equation, log to the base 3 of x minus 4 plus log to the base 3 of x plus 4 equals 2, I will use the sum property of logarithms to combine the two different logs on the left side. So I'll have log to the base 3 of x minus 4 times x plus 4. And then on the right side, there's still just the number 2 there. And we can change forms here. If you remember how to change forms from logarithmic into exponential, we're going to have 3 raised to the power of 2 equals x minus 4 times x plus 4. I'll go ahead and expand the right side, so we have 9 equals x squared plus 4x minus 4x, and then minus 16. Then it looks like easy. It's just here to add 16 to both sides, giving us 25 equals x squared. So x would be equal to plus or minus the square root of 25, we get x equals -5 or x equals 5. But one thing about solving logarithmic equations, we need to check the domain of these answers before calling them answers. So that if you remember the graph of a logarithm like the log of x, log to any base of x, is going to be defined when x is strictly greater than 0. And so I can only be taking the log of some number that is greater than 0. So let's look at, first of all, this x minus 4. If I plug in -5, that would mean I would be taking the log of -9. That can't be done. Whatever I put into my logarithmic expression has to be greater than 0. What about 5? Well, 5 minus 4 here would be positive. 5 minus 4 would be equal to 1, so we're okay there. I check each logarithmic expression here, so if I plug 5 in for x and x plus 4, I would be taking log to the base 3 of 9, and that's okay. So as long as we have a positive argument for our log, we're all right, and our answer here is x equals 5. Now let's solve the logarithmic equation. Log to the base 121 of 2x plus 3 equals log to the base 121 of x minus 4 plus 1/2. In this case, I think I want to get both logarithms on the left side, so I'll subtract log to the base 121 of x minus 4 from each side. Then on the left side, that results in log to the base 121 of 2x plus 3 minus log to the base 121 of x minus 4, and then equals 1/2. Okay, combining these logarithms, I can use the difference property to get log to the base 121 of 2x plus 3 over x minus 4. This is equal to 1/2. And again, we can change forms here. If I change forms into the exponential form, I will have the base of 121 raised to the power of 1/2, and this is equal to 2x plus 3 over x minus 4. The square root of 121 is 11, so I have 11 equals 2x plus 3 over x minus 4. I multiply both sides by x minus 4 and distribute that 11 through to get on the left side 11x minus 44 equals 2x plus 3. And let's see, if I subtract 2x from each side, the left side would be 9x. I add 44 to each side, giving me 47 on the right side. Then we can solve for x. X would be equal to 47 over 9. Okay, but remember, we need to check the domain here. Okay, so before calling this an answer, let's check. If I plug 47 over 9 into x for 2x plus 3, I'm going to have a positive number. That's all I need to know. I'm good there. What about x minus 4? 47 ninths minus 4. Oh, let's see. Would that be positive or negative? So 47 over 9, it would be bigger than 36 over 9. So 36 over 9 would be 4. Yeah, so if it's bigger than 4, we're good. So x equals 47 ninths is a solution here. And I'll put a little plus sign up there. Okay, try in your own number 3. Solve the logarithmic equation. 4 times the natural log of x plus 3 equals 4 minus the natural log of x.